Students, we are going to be doing inverse functions. And inverse functions are kind of fun. It's when you have an equation, y equals mx plus b, or y equals something with an x value, and you just switch places with the x and y and solve again for y, and you learn what your inverse function is. And so we're going to just see some graphs of inverse functions. We're going to just practice changing functions, finding their inverse functions, and so forth. So let's go ahead and take a look at inverse functions. So an inverse function in section 3.2, we defined a function as a set of ordered pairs x, y, such that for every element x in the domain, there corresponds exactly one element y in the range. We talked about how there could not be two x values with different y values. The x can only have one y value. And so we have learned a little bit about that. We're going to move on with that idea in mind about a function. We could have the function of deli meat and a weight, right? X to its cost, the weight of the meat with its cost. If we have 1 pound, it's $4. If we have 2.5 pounds, it's $10. If we have 4 pounds of meat, it's $16. So that's a relationship between the weight of the meat and its cost. Okay, that's called a function. And we kind of looked at that. And we could graph that. But what happens if we changed it? What if we said, instead of 1 being x, we move it over here to the y value, and instead of 4 being y, we moved it to the x value. And that would be called an inverse function. And we write that like this: f inverse, -1 means inverse, and it relates the price of meat x to its weight. So the price to its weight, price to its weight, price to its weight. Where from here it was its weight to its price, weight to its price. Here the inverse just switches the x and y values. It's called the inverse function. The domain of f is the same as the range of f inverse, and the range of f is the domain of f inverse. So we're going to talk now about a one-to-one function. We'll practice this. We're just getting some of the definitions out of the way. A necessary condition for a function f to have an inverse function is that no two ordered pairs in f have different x coordinates and the same y coordinates. So remember, a function, we couldn't have 3 and 2 and then 3 and a -5 because we'd have the same x coordinates. But this rule also applies to the y coordinates. I couldn't also have two y coordinates that had the same, or y that had two different x coordinates. So that would be 1-to-1, that it only could match up 1-to-1. And then, in other words, we're not going to be stating both ways. 1-to-1. So let's just look at these and see if we've got, let's just first of all see if they're a function. We've got a 4, a 1, a 3, and a -4. That is a function. Now, if the y values repeats, it's not a 1-to-1 function. 2, 2. Oh, look, the y value repeated. So this is not 1-to-1. It is a function, but it's not 1-to-1. Let's look at this one. Is it a function first? 0, 5, 2, 5. Uh-oh, I've got a double 5. This is not even a function. And finally, let's look at this in 3, 2, 0, -1. Okay, that works. 4, 2, 8, 7. I didn't repeat anything, so this is 1-to-1 function. And that's what we're looking for. So no x values repeat and no y values repeat. And you can use the horizontal line test. And if I can draw a horizontal line through it, if I can, and I touch more than one point, then it's not 1-to-1. But if I can't, then it is 1-to-1. So here's a horizontal line. I hit it once here. I hit it once here. Therefore, we know that this is not 1-to-1. Notice they draw a line. Hit it once there. Straight line once through the whole graph. It's not 1-to-1. But look at this. If I draw a horizontal line, I only hit it once in that graph, don't I? So this is a 1-to-1. That's also a function this way too, 1-to-1. So looking here, if I draw a line, I hit it. There's my straight line once, twice. So 4 is not 1-to-1. If I do it here, I only hit it once. See if I could do it again. Yep, I only hit it once. Yep, I only hit it once right there. So this is yes, 1-to-1. Okay, so now the definition of the inverse of a function. We've kind of played with some ideas. Now we're going to look at the definition. If f is a 1-to-1 function represented by ordered pairs of the form xy, then the inverse function denoted by f inverse 1 is a set of ordered pairs given by yx. So if f is a 1-to-1 function, then g is the inverse of f if and only if f composite g equals x and g composite f equals x. And we're gonna look at this. This is our way for proving that two functions are inverses of each other, is if I can substitute one into the other and get x as the answer and do it backwards the other way and get x as the answer, then we know they're 1-to-1. So here I have the function f 5x plus 4, and I have this function x minus 4 over 5. Now to show that they're inverses, I have to show that f composite g equals x and g composite f equals x. That's what I have to show to prove that they're 1-to-1. So if I start with f composite g, I put g of x in here. So I'm going to put wherever I see, I'm going to put this whole thing right here, wherever I see that. Okay? And that's what they do, but look, these 5s will cancel out. I'm left with x minus 4 plus 4. They cancel out. And what am I left with? X. So the first half of my proof is true. But now I've got to prove G composite F. This time I put this into here. So 5x plus 4, subtract 4. These 4s will cancel out. 5x over 5, the 5s divide out into being a 1, and I'm left with x. So both, when I did the composite function, f composite g or g composite f, they both turned out to be x. This is 1-to-1. So let's try it here. 3x minus 2 and x plus 2. So first we're going to try f composite g. That means I'm going to put this into here. So 3 times x plus 2 over 3 minus 2. Well, these 3's just become 1s. They divide out into 1s. And I'm left with x plus 2, subtract 2, which really gives me just x. So that checks. Now we got to check, does g composite f work? And so I put 3x minus 2 plus 2 all over 2. All over 3, sorry, that's a 3. All over 3. These two cancel each other out. And then 3 divided by 3 is a 1. That also makes it x, so check. So this is 1-to-1. Now, how do I find an equation of the inverse of a function? This is the fun part. Well, this is the easy part too, in a way. So you take your equation and you just switch the x and y's in the equation and then solve again for y. And then whatever you get is the inverse function. So here's our function. First of all, I'm going to just rewrite this as this. That's the first step, is always change this to y, okay? That's the first step that you'll take. Then switch x and y places. Then solve for y. They subtract 1 from both sides, divide by 2. So this, then what I do is I replace this with f inverse x. It should be a -1. And that's what they do. F inverse x is equal to x minus 1 over 2. Now, here's what's cool about it. Here is the graph f of x. Here is the graph f inverse x. And there's an axis of symmetry right through the origin that these guys could fold over on. If I folded this line, if this was paper and I folded right here, this would map right onto here, and this would map right onto here. Okay, so here we have it. First step, rewrite it like this. Second step, exchange places with x and y. Third step, solve for y. And then finally, replace the y with the f inverse of x. And this is my answer right here. So I have a way to prove it by doing F composite G and G composite F, and then I have a way of finding what they were by exchanging the X and Y's and solving for Y. Find the inverse of this one-to-one function. Okay, so this is really Y equals the cubed root Now I'm going to change places with X and Y. Now I'm going to solve for Y, so I'll add 4 to each side. And then to get rid of that, I'm going to cube each side. And I'm going to let you see how that works. So I'll erase all my writing so we can see it. And when I do all the multiplication for that, I'm going to divide by 5. And I can just leave this like this. So here is y equals, now what do you need to do here? Just exchange it back for G inverse, right? Yeah. And this is kind of how this graph would look. Right here's the axis, the y equals x line. And this is how they would cross over. If I folded, they would fold right on top of each other. All right, here we go. Y equals cube root of 2x minus 1. Since this minus 1 is included in the square root, I'm just going to cube. Oops, I'm going to trade places. And then I'm going to cube each side to get rid of the cubed root. And then x to the third, I'm going to add 1, it looks like. And I'll divide by 2. So my h inverse of x is equal to k. So finding the equation of the inverse function, now x has to be greater than or equal to 0 for this to work. Because if x is less than 0, this inverse function won't work. So here we go. We're going to rewrite this as y equals. Here's the graph of that. So the inverse, here's our line, is going to be over here like this, isn't it? Okay? But we are only going to be concerned about this half right here because it says for x being greater than 0. So when we do that, this is our axis. We'd fold over, it would be kind of like that. So we let y equal that. Now exchange places with y and x. Now we're going to solve for y. Take the square root, and we get that. And let's look at that. So m inverse of x is equal to the square root of x minus 4. Interesting that quadratics inverses are square roots, aren't they? And notice that's how it looks, just kind of like I was suggesting. it would look. Okay, we're going to try it here. So for this is our graph. It's shifted down to basically from the parent function, right? And we're finding its inverse. So it's like what I get if I folded on that line? So y equals x squared minus 2, or x equals y squared minus 2, or x plus 2 equals y squared, or the square root of x plus 2 equals y, and I can only do the front half of it, the positive half of it, okay? But this is, oh, then we want to write it in its formal form, inverse of x, like so. And that is the end of it. We are going to go to our homework. Good luck with that. Remember, there's those other videos to always watch to give you, and hopefully you're watching all of the videos. And we're getting ready to get into our final. So make sure that you're understanding chapter 8. So we will see a little bit of chapter 8 on the final. It's not very heavy on it, but you're going to see it. Good luck on this homework. If you have questions, please contact me so I can help you through it.